Okay, when we're working scientific notation, the goal is to get the decimal after the first non-zero number starting from the left. So as we can see in number 1, we have the number 3,400. Looking from the left, the first non-zero number we get to is a 3. So our decimal goes after that first non-zero number, and then we complete the rest of the number 400. In scientific notation, we're always times 10 to some power. And to determine the exponent that we're going to use, we have to determine how many times we had to move the decimal to get it to where it needed to be. Well, you know, with a whole number, the decimal is always at the end of the number. And then it's just counting one time to get it there, 2, 3. It took us 3 moves to get it where we need it to be. So because the original number was 3,400, which is a number larger than 1, it's going to be a positive exponent, 3. Similarly, for number 2, we are starting with a number that is smaller than 1. It is a decimal number. Again, we have to take a look, starting from the left, find the first non-zero number. As you can see, we have a bunch of leading zeros, and it's not until this point that we reach a non-zero number, the 2. So the decimal goes after the first non-zero number from the left, 2 point, complete the number 3, always times 10, and then it's just a matter of determining what our exponent should be. And we got to count how many times we had to move this decimal to get it where it ended up. 1, 2, 3, 4, 5. So it was a movement of 5 decimal places. And in this case, because we started with a number that was smaller than 1, small numbers have a negative exponent. Okay. For number 3, we can see that we have a number that's large, which means we're going to have a positive exponent. We start from the left, look for the first non-zero number, and there it is, the first number. So we're going to go ahead and put our decimal after the first non-zero number and then just complete the number. Again, it's scientific notation, so it's always times 10, and the decimal was originally at the end, so it was simply movement of 1, 2, 3, 4, 5 places to get it there. A larger than 1 number requires a positive exponent.